it goes from simple to compound, from non-functional to functional. There's already a beginning of this 1, 1, 2, because we repeat this in the second. That is to say, the repetition is the compounding. Here the repetition is from non to functional. In the next one, this is going to be, they're called non-functional polymers. I'll just say non-F polys. And these become functional polymers. Now, I don't want to just confuse you with titles, but I'm concentrating on the name because that's a clue to what's going on. You go from non-functional to function, from non-function to function. That's twice, so you've repeated that 1, 1, 2 thing. To show you now what this symmetry is, because we've got an arc, but an arc of molecules. What's common to these two, the methane series, is the covalent bond. This points to here, by the way. It's the polymers that are the non-functional. So that matches this non-functional. They're both non-functional. And it's because of this covalent bond, this bond that's like a marriage contract. Whereas here was where my theory was predicting. And I didn't know that much about chemistry until I read carefully. The ionic bond which holds the salts together comes in again here. And the interesting thing is, in the case, here are these two chemicals, actin and myosin. And it's almost like a firecracker or a bomb. It's ready to go off. But the ionic bond is used to prevent them from discharging, whereas the ionic bond here holds them locked. It's the use of the ionic bond here, whereas this one is used by the ionic bond. It's similar here. The covalent bond here keeps them out of circulation. The covalent bond here makes it possible for this chain to stay chained together and not fall apart when it goes into chemical solution.